Today we are reviewing prime factorization and changing fractions to decimals and decimals to fractions. Please copy the standard benchmark indicator on a clean page in your math notebook. The student will identify representations of a given percent and describe orally and in writing the equivalent relationships among fractions, decimals, and percents. The student will find common multiples and factors, including least common multiple and greatest common factor, identify and describe prime and composite numbers, and identify and describe the characteristics of even and odd integers. Prime factorization. Every whole number greater than 1 is either a prime number or a composite number. A prime number has exactly two factors, 1 and itself. A composite number has more than two factors. The numbers 0 and 1 are neither prime nor composite. Example 1. The factors of 185 are 1, 5, 37, and 185. Is 185 a prime or composite number? Since there are more than two factors of 185, the number is a composite number. Try it. Given the number and its factors, tell whether it is prime or composite. So for A, 25 has more than two factors, more than just one in itself, so we know it's composite. B, 83 only has 1 and 83 as factors, so we know it's prime. For C, you have 54, and we know it has more than 1 and 54 as factors, so we know it's composite. Finally, D, 68 has more than two factors, so we know it also is composite. Example 2. Write the prime factorization of 50. Tell whether it is prime or composite. To decide if a number is prime or composite, you need to find the factors. You can use a factor tree to find the prime factors. The prime factorization is 1 times the number is a prime number. If the prime factorization is not 1 times the number, then the number is a composite number. Here are two factor trees that show the prime factors of 50. On the first one, they do 10 times 5. Second one, they start with 2 times 25. But you notice all the prime factors are the same as they finish the tree, and they've circled them on each tree. So we have 2 times 5 times 5 is the prime factorization for 50. Since the prime factorization is not 1 times 50, it's a composite number. And if you notice, in the prime factorization, the numbers are always listed from least to greatest. Try it. Write the prime factorization of each number. Then tell whether the number is prime or composite. So we're going to start here with E with 18. So we're going to draw that. And we're going to start by picking two factors of 18 that we can multiply together to get 18. So we'll start with 2 and 9. We know 2 is prime, so we're going to go ahead and circle it right now. And then we have 9, which we know to get 9 is 3 times 3. And then we can't go any further because all of the numbers at the edges of each branch are prime. So the prime factorization of 18 is 2 times 3 times 3, or 2 times 3 squared. For F, we have 23. 23, we cannot divide any numbers into, so we know it's prime. So its factor tree is just going to look like 1 times 23. So that way we can prove 23 is prime, whereas we know 18 is composite because its factor tree is not 1 times 18. For G, we have 27, so we're going to write the number out, and we know 3 times 9 gets us 27. We know 3 is prime, so we're going to circle it, and then we know to get 9, we multiply 3 times 3. So the factor tree for 27 gives us the prime factorization, which becomes 3 times 3 times 3, or 3 cubed, which means it's composite because it's not just 1 times 27. For h, we have 60, and so we're going to start with that. We know 2 times 30 will get us 60. We know 2 is a prime number, and we know you can get 30 by multiplying 2 times 15. Again, 2 is prime, so we circle it. 15, we're going to do 3 times 5, both of which are prime numbers. So our prime factorization is 2 times 2 times 3 times 5, which tells us it's composite. Next, we have 93, and we know that 93 is 3 times 31. So we're going to write that one out. Both of those numbers are prime, so the prime factorization for 93 is 3 times 31, which means 93 is a composite number. Finally, we're going to do 115, which we know is 5 times 23. So that makes 115 a composite number. Continuing on, we're going to look at how to turn a fraction into a decimal and decimals into fractions. So to turn a fraction into a decimal, divide the numerator by the denominator. So to take 1/2, you set up the problem. The numerator always goes in the house. The denominator is always outside the house. 2 doesn't go into 1, so we put a decimal. We add a 0. 2 goes into 10 5 times, so 1/2 is 5/10. To go from a decimal to a fraction, place the decimal over the correct number, 10, 100, 1000, etc. For example, 6/10 is 6 over 10, and then you would simplify to 3/5. 87/100, you just put the 87 over the 100, and you can't simplify any further on that one. Sometimes you may have to simplify to get the simplest form of the fraction. For the sample problems, we're going to take each fraction and turn it into a decimal. So we're going to start with 1/4. So we're going to divide. We're going to put the 1 in the house and the 4 outside the little division house. So when we divide 1 by 4, we get 25/100. For 2, we're going to do the same thing, 3 divided by 5. And 5 goes into 36 times, so we get 6/10 for our decimal. Finally, for 3, we have 9/10, which we don't even have to divide because we can hear it as we say it, so we just have to write 0.9. Now we're going to turn each decimal into a fraction. So we're going to start with 8/10. As we look at that, we know they share a common factor of 2, so we're going to divide the top and the bottom by 2 to get 4/5. For 5, we have 93/100, so we're just going to write 93 over 100, and we can't simplify. Finally, for 6, we have 61 thousandths, and again, we can't simplify that any further. Please make sure you have all the work copied down and glue the pages in your math notebook.